Okay. All right, a couple of things. Over the weekend, I worked on the real final. And hopefully not.
Yeah.
That led me to make some changes to the formula sheet. So I updated the practice test for the formula to reflect changes in the formula sheet. So I included a few fig identities on that.
Good thing I waited to print it.
But
Good thing I waited.
yes, definitely.
Like this.
Also, because I'm not sure how it's gonna go as far as the length of a test, for 20 problems altogether. So instead of having 20 problems, 5 points each, for a total of 100, it's gonna be 20 problems, 6 points each for a maximum possible score of 120, but out of 100.
So we have some room for error. We mess up.
Yeah, so another way to think about it is, if you want a perfect score, it's enough to do 16 2/3 problems correctly. And then anything above and beyond that is bonus. And one of the one of the problems already has a bonus in it. So that would mean that the maximum possible score, if I guess it'd be 126. So much for some of you to shoot for.
So we have some room for error.
A good amount of room for error, yeah. Or if you need to, you have 2.5 hours. So if you need to budget the first half of that hour being, like a freak out, then you have time to recover from it. And yeah. That's why, like, in the Monday, Wednesday, Friday format, 50-minute classes, a test during that kind of a time slot is killer, because after you recover from your freak out and you have no time left. Okay, so that's one item. Right, now the other item concerns one of the homework problems. Something strange came up. Now it's a homework that the due date has already passed, but in case anyone's using late passes, then this is still relevant. This was homework.
The one where it was like, for finding, like the area.
Yes.
Yeah, because I went through it and I even talked to like a friend of mine who is like a calculus professor, and he went through with me to make sure it was right. He still got the wrong answer.
Yes, so, okay, so this is problem number, 12, homework 11. All right, so formula for area of this region, where the top boundary is described by a parametric curve and bounded by the x-axis, and T is restricted to the interval AB. So the area is plus or minus integral from AB of okay, so y times derivative of x. Now plus or minus is depends on whether the parametric curve is traced out from right to left or left to right. So ideally that's the formula you should use. However, there's something wrong with this problem. So to get the right answer, as I checked this, I had Wolfram do the integral for me just in case. The problem expects these to be flipped. X of t, y prime of t. And then you will get the right answer.
Because I asked about this in class and I figured out, I was like, well, what if I put it in terms of y instead?
Yeah.
And it gave me the right answer. I was like, okay.
Yeah. Now, this would be the actual right thing to do if it was this kind of region where y equals 0 is the boundary, and you still have this parametric curve. So this area formula applies to this one. you're integrating x dy rather than y dx. Okay, so, yeah, because on the whim, I just tried that and it's like, oh, that's what they want, because I can look at the answer key. And so what I did was I went through over a weekend, see, okay, for this problem, who has gotten it wrong and who actually got the correct and who got the answer that I taught you to get, who used the correct method, got that answer and had it marked wrong. There was only one situation where it actually applied. I went in and gave full credit to that person. So, whereas there are other cases where it was just wrong all the way around, no matter how you sliced it. So yeah, whoops. But I guess that's what happens when you have an online homework system where anybody can contribute questions. Whereas, yeah, there was one other area problem that was of a very, I imagine was written by someone else. And where wasn't that issue? Okay. All right. So already other homework issues. All right. Now, I have one section left to cover. That's again not going to be in the final. And there's homework. It's homework 13. But one of the lowest homework will be dropped. So I will admit to a certain laziness in preparing these notes. That what I did was I just went through the homework drops. And added explanation where needed, but it's definitely not a thorough, comprehensive treatment of all things conic sections. Okay. So now we're really just going to be a discussion of how to work out certain problems involving conic sections that happen to appear in your homework. Also, owing to my laziness, I didn't have any graphs prepared to help explain things about parabolas, ellipses, or hyperbolas, but I can add those pictures here in the board. Yeah. Okay. So, what characterizes these three kinds of conic sections we'll see? Parabola, ellipse, or hyperbola. Okay. So here's an example of a parabola, looking like y equals x squared. And what characterizes all the points on a parabola, that if I draw this, in this case, a horizontal line, which is located at the coordinate y equals minus f. And this line is called the directrix. That's kind of sci-fi in a way.
Directrix.
It's kind of begs for a trilogy or something.
Yeah.
Oh, well, pre-conic section stuff, there you go. And then there's a point here called the, this is an example coordinate 0, f. So these f's are the same, so it'll be positive f here and minus f here. This is called the focus. Okay. That if I take the distance from a focus to any point xy on okay, let's write as P, which has coordinates x and y. This is from the point P to the focus, and I'll call that capital F. And then the distance to the directrix. Okay, so I'll call this distance EL, where L is the point on the directrix that is nearest the point P, so basically perpendicular distance. And then this distance is PF from a point to a focus, that these two distances are equal. So every point in the parabola satisfies that it is equidistant for both a focus and the directrix. In this example, the directrix is a horizontal line, but it can be any line. So that would just affect the orientation of your parabola. And you can, if you express this equation in terms of x and y, then you can come up with an equation for a parabola, like y equals x squared, or squared, things like that. Actually, the okay, I'm not gonna have room for these. I'll get to these later. So more generally, there are two cases I'll focus on. If the vertex is at the point, oh, sorry. This is a vertex. Okay, the vertex is at the midpoint between the focus and the directrix. Okay. So a vertex is given of a point of V1, V2. And then the focus has the same x coordinate, but the y coordinate is one of the vertex plus f. Right. In that case, a directrix has to be the line y is equal to v2 minus f. The fact that the x coordinates of a vertex and focus are the same, that tells you that the directrix is going to be a horizontal line. So, so if you have any old vertex, any old focus, the distance between them is this number f. And then you go in the opposite direction, and the line perpendicular to this line is directrix. Now, for the homework, we only care about the simpler cases of directrix being horizontal or vertical. But if I had this kind of setup, then that'd be my parabola. Badly drawn, but okay.
Okay, is that V2 plus F?
Yes. So in this case, I can tell you what the equation is. That can be derived from this. The y is equal to 1 over 4f, whatever f is, and then x minus v1 squared plus v2. All right. Now, the opposite situation is if the vertex is again at v1, v2, and the focus is at B1 plus F B2. So now the Y coordinates stay the same. The X coordinates are different. So in that case, the directrix is a vertical line. X is equal to B1 minus F. And the equation, really it's going to reverse the roles of X and Y. So X is equal to for F, Y minus B2 squared plus B1. So the first two homework problems are all about what's right here. Is that you're given a vertex, you're given a focus. Based on which these coordinates are changing, it tells you which kind of parabola it is. Directrix y equals something or x equals something. And then the appropriate equation from these. So not terribly interesting, but example, suppose we have focus. Is that 5 and 4? Text is at 4, 4. Based on which coordinates changing and by how much. What would the value of little f be? Using these relationships here.
Oh, it's, the second case.
Mhm.
It is the second case. Yeah, because the y coordinate of the 2 points are the same. Okay, so what's the actual numerical value of f? -9. So the idea is, okay, so V1 is taking from a vertex, so that's 4. V1 plus f is equal to -5. So you substitute that in there. And you get it's -9. Okay. Well, actually, yeah, that's your equation. There's nothing more to do. So you just fill in the pieces. If X is -1/36, 4 times 9, and then you have Y minus B2, which is 4. Squared plus B1, which is also 4. So and the directrix would be the line X is equal to V1, which is 4 minus F, so the directrix would be 13. Yeah. So that's the other thing is the homework problem asks for, what is the equation of a directrix? It's B1 minus F. Any questions on that one? The other one. So, your focus is at, 5, 0. Vertex, that's 5, 2. But -2, yeah. So we have B2 equals 2, B2 plus F 0, but F is -2. Okay. All right. Okay, which one of these scenarios is it? It's the first one because the exponent of the focus and vertex are the same. So now you can go ahead and write your equation. So we have -1, 8, so 2 times 4, x minus v1, which is 5, squared plus v2, which is 2, and the what is the directrix in this case?
4.
But the full equation of a directrix, y equals 4. All right, so it's v2 minus f, but f is -2. 4. Okay. Love these. Okay. So that's a problem. Next is ellipse. So the ellipse has 2 points that each serves a focus of our foci. Foci, I'm gonna try to pronounce it to be honest. So foci in this case are in this example, the longer the axis along which the ellipse is the longest, that's called the major axis. So in this case, the x-axis. The line, but in general, the line that contains the 2 foci is a major axis, and then the line perpendicular to that, that also passes halfway between the foci, that's the minor axis, in this case, the y-axis. Right. Now, what characterizes all the points on the ellipse is if I pick any point on the ellipse and examine get the distance from that point, I'll call this point F1. That has these coordinates. And this one is F2. And here's my point P on the ellipse. Coordinates X, Y. So this distance is EF1. This distance is EF2. That the sum of the two distances is equal to a fixed value for any point on the ellipse. And that value I'm labeling as 2A, where A is the distance from the center to the point, our point that sits on the major axis. Now, if I call this distance from the center to points in the minor axis, I call that B. Then what we have is if I choose my point P to be sitting on the minor axis, we get a right triangle. And we have this relationship that A squared is equal to B squared plus C squared. Now, in general, if the ellipse has a center, like this ellipse has a center at the origin. But in general, if the ellipse has a center, x naught, y naught, then the equation is x minus x naught squared over a squared plus y naught squared over b squared is equal to 1. Now the points that sit on the major or minor axis, those are called vertices. But like a parabola that has just one vertex, an ellipse has 4. So the vertices are x naught plus or minus a and y naught. Are two of them, and the other two are x naught and then y naught plus or minus b. Where a comes from a term involving x, b comes from a term involving y. In this example, a is greater than b. The foci are sitting on the x-axis. This area written here holds whether a is greater than or less than b. If b is the greater, then the foci sit on the y-axis. But you'll need to know that to compute the vertices. So the one homework problem I have involving ellipse is just this: you're given a center and the equation, one of the 4 vertices. So even less interesting in the parabola problems. So as an example, well, actually, yeah, really stuff the equation that you're given. Because from the equation, you can get to center. Okay. So. So what do we got? Whatever this center and then the vertices. What are 4 vertices?
2 minus
8 and 2, and then.
minus 2.
Mhm.
We would have 3, 6, and 3 minus 4.
Yep, yeah, just take, y coordinate plus or minus 4. Paired with, the x coordinate, and then the x coordinate plus or minus 5. Paired with the y coordinate. And that's all there is to it. One conic section left. The hyperbola. Okay. So like the ellipse, the hyperbola also has 2 foci. So in this case, I'm going to situate them. So this here is center. First of these homework problems will be at the origin. And here are foci are minus C0, C0. Okay. Now, between the foci are vertices. So unlike the ellipse, the vertices are closer to the origin than the foci. So we have minus A, 0, and A, 0. Okay. Now, the hyperbola passes through the vertices, and it's going to look something like this. Two curves. And in this case, the equation, so we have, this is because of foci are sitting on the x-axis, then this is called an east-west opening for hyperbola. And the equation is x squared over a squared minus y squared over b squared is equal to 1, where b squared is c squared minus a squared. Now it characterizes all the points on a hyperbola. So they have some point on either one of these curves. And I examined the distance from that point to the foci. So now the absolute value of the difference of the distances is equal to a fixed value, which turns out to be 2a. Unlike the ellipse where it was the sum of the distances that was constant. And that can be used to derive this kind of equation. And like the ellipse, the x-axis, whatever axis the foci sit on, that's the major axis. On the other hand, if the foci sit on the y-axis, 0c, 0 minus c, again, we're assuming it centers at the origin. And the vertices are 0a, 0 minus a. So everything's sitting on the y-axis, but this is called north-south opening. So you would basically take this picture and turn it 90 degrees. So then the equation is y squared over a squared minus x squared over b squared is 1. And b is the same as before, c squared minus a squared. So the homework problems, there are two on hyperbola is you're given the foci, you're given the vertices, you're supposed to figure out is it east-west or north-south opening, and based on that, write down the equation. Okay, so we have and we've been assuming all along center at the origin, otherwise there would have to be shifted. Okay, so we have foci in this case are 0, 2, 0 minus 2. Vertices are at 0, 6, 0 minus 6. Okay. So the goal is to come up with the equation. Wait, hold on. I'm sorry, I had this totally backwards. These are vertices. 0 plus 1 to the these are plus 1. What kind is it? Okay. numbers that should go underneath.
36 and 4.
Not 36,
Square root of 42.
but okay. Well, don't forget, it's a squared and b squared that go down below.
Square root of 4. 4 and 3.
I'm sorry, what?
That's 60 now.
Yeah, so 4 goes here.
36 minus 16.
No,
36 minus 4 square root of
yeah, 32 is what goes down.
stored out there.
Yeah, so A is equal to 2 from the vertices. C is equal to 6 from the foci. So then B is not the square root of 32, but B squared is what you feed to the feeders in the equation. You want to see how it goes? Oh. Oh, I guess there's only one problem in the homework on this. Number one. No. Okay. All right. Yeah, so. So vertex into A, both sides into B, and then you Pythagoras it to get B. Let's make that up. Now, so far I've been dealing with just everything Cartesian coordinates, but you can also describe conic section in polar coordinates. And in this case, all the equations pretty much have the same form. Okay. So going to assume that at least one focus of a conic section lies at the origin, just to simplify matters. Okay. Now, so here are possibilities. If a directrix is that x is equal to p, and p is positive, right? Then the polar equation of your conic section is of this form: R is equal to E times P over 1 plus E cosine theta. So E is referred to as the eccentricity of the conic section, and the value of E, it's always a positive number. The value of E tells you which kind of conic section you're dealing with. So E is less than 1, it's ellipse. E equals 1, it's a parabola. And E is greater than 1, it's hyperbola. If the directrix is x is equal to minus p, then it's almost the same thing. You just have 1 minus e cosine theta. So whenever you have a vertical line through your directrix, you always have e times p over 1 plus or minus e cosine theta. The other two possibilities are directrix y is equal to p. Pretty much the same, except it's sine instead of cosine. 1 plus E sine theta. And this y equals minus P for directrix. And R is equal to EP over 1 minus E sine theta. There are 4 homework problems dealing with polar equations, where you go back and forth between, I'm a given polar equation, figure out the directrix and eccentricity, or vice versa. Okay, so both were given. I think it's over 1 minus 7 cosine theta. So we'll figure out the eccentricity E. What is the directrix? X equals something, or Y equals something, and so what is it? And what type of conic section is it? Ellipse, parabola, or hyperbola, say like a multiple choice thing. Or drop down in homework. Okay. So you're basically taking the given polar equation and fitting it to one of these 4 forms. So really going to be figuring out E and P together. Remember, P is positive. E is what? E and P are always positive, because notice equations have plus or minus built into them. Yeah, so E is 7. All right, and therefore what is P? Yeah, to make sure that the product is profitable. It's 6. Okay, so then, what is the equation of the directrix? Based on the scenario you fit the equation to.
X equals -3.
Yeah, so X is equal to minus 6/7. This X because it's cosine. It's minus because there's a minus here in the denominator, and then the value of P. What's next? And what kind of conic section is this? It's hyperbola because the eccentricity is greater than 1. That's value E that dictates. Right. Questions on that one? Howard? R is equal to 1 over 4 minus 2 cosine theta. Be careful when you fit this one to one of the 4 forms here. Those same things to find. What's E? But yes, because you have to divide the top and bottom. This has to be a 1. So divide top and bottom by 4. Hopefully, the one would fall to that trap, but good on you for not. Yeah, so E is 1/2. Okay, what about, P? Yeah, P is also 1/2, so the product of top is 1/4, okay. So what do you got for directrix?
Negative.
X or Y?
Okay.
Yeah, X equals -1/2, and this conic section is, it's an ellipse because the eccentricity is less than 1. Um, Questions on these two? All right. Last one. It's not gonna be the other way. Okay. You're given a directrix. Y is equal to 4. And the eccentricity is equal to 1. Okay. So the question is, what is the polar equation? And what type of conic is it?
Parabola.
Yeah, it's a parabola because E eccentricity equals 1.
Plus sign.
Yeah, plus sine theta.
4 on top.
Yeah, 4 on top is because P is equal to 4. Okay. The other hand, that we have X equals -5 and E is equal to 2. Hyperbola. E is greater than 1, so it's a hyperbola.
It'll also be fine.
Negative 10.
Yeah, E and P are both positive, but yeah, 10 up top. Yeah, to cosine theta because X equals, you have a minus here is reflected there. I guess I could have condensed these two into one equation if I write 1 plus E times P over absolute value of P cosine theta, which is also known as the sigma function, but either way. So, okay, that's all I got, like, before the semester. Well, okay, there's a review on Wednesday. Yeah, but in terms of new stuff, it's there. Thank you. So be sure to take some time to kind of attempt practice common problems. Any issues with those?